Hello students, today we shall discuss about the reversal of polarity, cyclicization and summary of strategy. First of all, here reversal of the polarity. What is the use and why we are taking this type of thing in this disconnection approach. So in the last chapter we needed three type of synthon depending on the disconnection relationship in the target molecule. Okay, for the see here in this target molecule number 1 3 disconnection, 2 is this synthon, for this is the reagent, and for 1 2 disconnection there is two type of reagents, and 1 1 disconnection there is also two type of reagents. So for the 1 3 disconnection relationship we used just one synthon, molecule number 2. For the 1 2 disconnection we used synthon number 5 and 8, and for the 1 1 disconnection two more synthon we have used, like number 11 and 14. The synthons for 1 3 disconnection and 1 1 disconnection relationship could be turned into reagents number 12 and 15 simply by using the natural electrophilic behavior of the carbonyl group. The synthon 5 and 8 for the 1 2 disconnection relationship could not be turned into the reagent so easily. So the reagent number 6 does not resemble the synthon 5th, while synthon 8 looks very unstable and such intermediate cannot be made. That's why we need reversal of their polarity. We have to change the polarity of the synthons. Suppose this is the synthon number 8, and after the reversal of the polarity this cation converts into anion. Okay, and that 16 this is the 16 number of molecule, this is synthon, and for this reagent is this enol form, and that enol form, so that enol form after tautomerism it converts into ketone. So this 16 number of synthon, we discover a synthon, this is 16 number, that again uses the natural reactivity of the carbonyl group as and the enol, and that 17 number and then enolate in the equilibrium with the ketone by the tautomerism, and this 18 number of reagent react with the bromine in the acidic solution gives the alpha bromo ketone, alpha halo ketone number 9, and with an electrophilic carbon atom in the right place. Okay, and see that we have already discussed about the 6 epoxide number 6, and after the disconnection of 2 CO bonds then we get the 19 alkene. This is the reagent, and alkene is also naturally nucleophilic. So how we get the epoxide, how we get the epoxide as a electrophilic from the alkene? How? So in the presence of per acid, like metachloro perbenzoic acid. Okay, so in the presence of perbenzoic acid, the alkene converts into epoxide, and in the presence of bromine, dibromide is formed, which is electrophilic, naturally electrophilic. So this phenomena is called as reversal of the polarity, by which we get the reliable reagent for that 1 2 and 1 2 1 3 and 1 1 disconnection. For this 1 3 for this 1 1 2 disconnection. So here I have mentioned again that I have already told about this phenomena, and now we'll discuss about the halogenation of the ketone. Now, what is the analysis of this target molecule number 22? There is the carbon bromine disconnection bond, and the CBr bond disconnect. After the disconnection, we get the 23 is the reagent, reliable reagent, and after the carbon disconnection, we get the bromobenzene and MECOCl. For the synthesis of acetylation of the bromobenzene, the acetylation in the presence of AlCl3, then we get the acetyl group at the para position of to the bromo, and after that bromination in presence of acid, we get the target molecule. Okay, and here is one thing, that this type of synthesis is very straightforward. No bromination occur on the ring, as would be expected in the absence of Lewis acid, and enols react with bromine without the need of any catalyst. So the bromination was clear, as the ketone could enolize on one side only, and the reaction is suitable only for ketone that are symmetrical when blocked on one side, or which is enolized regio selectivity. So this type of reaction takes place. Now the halogenation of the acids, it is also very it is also it is clear in the halogenation of the acid that they can enolize on one side only. So reliable method for the bromination with PCl3 and Br2 and red phosphorus plus bromine. So we get the target molecule like 31. This is the halogenation of the acid. Okay, this is the this is the acid in presence of bromine and PCl3. It converts into molecule number 32. That and after that in the bromination we get the halo is the molecule number 33. Then in presence of base, it converts into this molecule number 34. Okay, if the reaction is quenched with the alcohol, only the acyl halides react, and this is the simple way to make the alpha bromo ester. Okay, then alpha chloro acids are these are the alpha chloro acid number 40. These are the amide group. This is the another example of the halogenation of the acid. This is the amide group, that molecule number 40. After the disconnection of carbon nitrogen bond, then we get the reagent, reliable reagent 41 and 42. Then disconnect the carbon nitrogen bond, then we get the aniline. So for the synthesis, aniline, first is the acetylation of the aniline, then because when we use the nitrating agent, then it is possible to there is possible to formation of the 1,2,3 trinitro, this compound number 44. So we use the acetylation. So we acylate the aniline before the nitration to prevent the oxidation or over nitration and reduce the proportion of the ortho nitration. So we get the molecule number 45 up to 60%. Then after the hydrolysis we get the we get the molecule number 42. Okay, then in presence of this 41 molecule, then we get the target number molecule number 40. Now we shall discuss about the cyclization. तो cyclization important reaction है. इसमें इंट्रामोलिकुलर जो reactions होती हैं वो generally easy होती है and faster होती है compared to intermolecular reactions. So generally intramolecular reaction are easier than the intermolecular reaction due to the entropy factor. This is the entropy factor, is thermodynamic factor. So when we talk about the formation of the acetyl, there is two type of reaction. We can make the acetyl from the methanol and ketone, and we can make the acetyl from ketone and diols. So in the presence of methanol, there is three molecules converted into one molecule, or in presence of diol, two molecule convert into acetyl. So entropy decreases, right? If you it is better to use the diol rather than the methanol, because the equilibrium is in the favor of cyclic acetyl number 48, but not in the favor of the methyl acetyl 46. This is the thermodynamic factor. And second factor is kinetic factor. The rate of cyclization to form the 3, 5, 6, 7 membered ring are greater than the rate of the corresponding bimolecular reaction. But the smaller loss of entropy is also a factor. So we don't expect a good yield in the acid catalyzed ether formation from 2 alcohol, because we get dimer of each alcohol as well as the mixed ether, right? This is the another example of the formation. This is this molecule number 52. In presence of acid, it converts into number 53. There is removal of H2 molecule, and this is the cyclization reaction. Okay, and if the compound is like this, number 56, so there is also 1,2 disconnection and 2 epoxide rings and amine. Okay, if there is this type of molecule, there is two type of possibility to disconnect the carbon. Two type of possibility number if there is a possibility carbon disconnect bond, and it will be formed by the Friedel-Crafts reaction, then we get the 56 reagent. If there is another possibility number B, that is carbon oxygen disconnection, then we get the diol, and this 57 is unstable. So the reliable reagent for this is this diol 59. Okay, now summary of the strategy analysis. Whatever we have discussed in the chapter 1, in the starting we have discussed about the some analysis and some synthesis. Now these are the summary of the strategy. In the analysis, first of all we recognize the function group in the target molecule. Second thing, disconnect with non-reliable reaction using function group interconversion as needed to give the right functional groups. We first of all we disconnect the bond joining an aromatic ring to the rest of the molecule, benzene ring ARX or ARC carbon. Disconnect any CX bond by bond next to carbonyl group RCOX using two group disconnection, and bonds in saturated ring as cyclicization is the best thing. And number third, repeat as needed to reach the available starting material. For the synthesis, first of all we have to write out the plan in the forward direction, adding reagents and conditions. Second thing, check the rational order of the events. And third point, check the chemoselectivity is favorable. And fourth is the modify the plan from point 2 to 3. So these are the things. Now in the next lecture we shall discuss about the amine synthesis. Okay, thank you.